What? Where's Fiona? Again? Yeah, no. Kidding me. All right. Shh. All right. So what we're gonna do is we're gonna kind of recap everything because we have a long weekend, and I know some of you guys kind of forget some stuff throughout the weekend. So let me recap everything on the sequence series, so that way when you're doing homework, you're not like, oh, I don't know what Stellar Skill series is. Huh? Yeah, that's what we're gonna do toward the end, and we're also gonna talk about alternative series test, which is a new test, which is that's probably the last real test, but there was also absolute and condition convergence.
Why do we need so many tests?
Because we had to finish all that, unfortunately.
I need more tests.
There's gonna be like one. It works or it doesn't work, and then you go all day.
I wish that happened. That make my job a lot easier. Trust me. All right. So I do agree with you. It's a lot of tests, and it's the problems like when to use what test is a really difficult part. So let me recap everything, so that way you know when to use what. So that way you don't go be like, oh no, that's crazy. Okay. So we're gonna start with 9.1, and we're gonna talk about sequence. And you have a question, you can ask me. So sequence is gonna be, well, sequence we're gonna deal with are they diverge or converge? All right. So we learn how to write sequence there. Basically, if limits n approach infinity of a to the n is equal to a, let's just say a number, then it's gonna converge into a number, right? So it can converge into a number. With a sequence, it's different, right? Sequence and series is a little slightly different. So you can converge into a number is fine. But with a in 9.1, we also talk about monotonic. What is monotonic again? Strictly increasing, right? So strictly, I can never spell strictly. STRICKLY?
No, it's another T.
TLY. Okay, strictly increasing. So if it's strictly increasing, it will prove by two separate ways. First way is by using derivative. And second is compared to a(n plus 1 versus a to the n. Or put like a(n plus 1 over a to the n. You compare one way or another. We're gonna show you kind of a little bit of both way today, and we're gonna show you how that work. Hopefully we can get there. We probably cannot get there.
What's the part? What is a(n plus 1 over a(n)?
Yeah, you compare the next term over the previous term. But we're gonna talk about that a little bit. Now, we also teach you how to simplify factorial. Do you remember how to simplify factorials? You have to get to the sim factorial for you to simplify. So those are very, very important later, not as of right now. Later on, we're going to do something called ratio test and root test. Then, don't worry, that's in the next test. That's this test on Friday. Which, by the way, test is on Friday because Thursday is Resilience Day. Friday is going to have a test of all the things I'm just talking about right now. Okay? So the next thing is 9.2. We start talk about series. What's the difference between series and sequence? Bennett, what's the difference between sequence and series?
A sequence is like a series is like the list that comes from this.
The what?
List. Yeah.
Sequence is list of number. What's a series?
It's like the. I don't know how to put in the words.
Yeah. So then you should be paying attention to me, not Misha and Nelly. So summation n equal to 1, infinity of a1. Then it's gonna including that a1 plus a2. This is a n. So this A1, A2, A3. So it's a sum of all terms, right? So you got a sum of certain things. Now, so we study, the first thing that we study about the sum is geometric series. So we have geometric series. What's geometric series? A1 over 1 minus R. Thank you, Benicia. And if R is greater or equal to 1, is diverge or converge? Diverge or converge? Diverge, good. Because ratio, you want it to, if it's bigger than 1, then that's going to get bigger and bigger. If R is less than 1, it's going to be absolute value less than 1. It's going to be converge, right? So that's geometric series. What'd you say?
0 R1, but the value is same thing.
Yeah, absolute value, yeah. So telescope. Telescope series is like usually that require, usually when the question is giving, require a, what else do you have to do? Require what? Partial fraction, thank you. Partial fractions. And when do you know you have partial fraction? You have a denominator is factorable. It's a factorable. So you do partial fraction. Hopefully you remember how to do partial fractions, and that's telescope series. And that's one of the two things that you can actually get infinite sum, which is s to the infinite. You can actually sum it up, everything. Now, does that happen on the first few terms with the telescope series? Maybe you have to write out a few more terms to see what's canceling. So last time we have homework question, you actually had to write down like 9 or 10 different terms to see like the first 3 middle is canceling or first 4 is canceling. Yeah, that's that. So geometric and telescope series. Now, one of the things that's very, very important to test, it should be the first test compared to every other test, is what? N term. N term is, I'm going to say this should be, this is a S summation, S infinite. You can get the actual sum when it go to infinity. Because that's only 2. You cannot do that with the integral test. You cannot do that with a comparison test. You cannot do that with direct comparison test. You cannot do that with harmonic series. But you can do it with geometric series and telescope series. That's only 2 things you can get. Another thing is N term divergent test. It should be the first test you run. First test. Because why you should do this first? Because today, yes, it's the easiest, and it's also gonna tell you it's diverge. If it's diverge, there's nothing else you need to do, because converge you have to have a lot of different options, right? So if a proof is something diverge, then it's done. No more work. But we talk about the n-term divergent test is when limits as n approach infinity of a to the n is not equal to 0. If it's not equal to 0, it's diverge. Series diverge. Right? This is very easy. But what happens when limits as n approach infinity of a to the n is equal to 0? Does that mean converge or diverge? This inconclusive. Thank you. But today we're going to talk about this inconclusive in alternative series. So inconclusive. It could be diverge or it could be converge. So that's like, okay, but however, this does tell me like one more thing though. This statement will be true though. N equal to 1, infinity of a to the n is equal to converge then limit n approach infinity of a to the n has to equal to 0, not converge. It has to equal to 0. Because only if it equal to 0, you have a chance to converge. Have a chance to converge, right? But if a series converge, then they definitely equal to 0. Sequence definitely equal to 0. Hopefully that makes sense for you, but this is a little bit about n-term divergence test. And we kind of did this a couple times, and we get to talk about integral tests.
Mr. Yan,
Mm-hmm.
will the question, like, if you were to use the n-term divergence test, will it give you the summation first and then ask you if it's if it diverges or
If if I told you a series converge, so ideally, if the series is actually converge, the limit of the sequence going to infinity has to equal to 0. It's have to. It have to equal to 0. Is that okay?
yes, I'm just confused because I can't tell like if it's a sequence or a series because if the sequence goes to a number then it converges. But if the
No,
series,
if a sequence go to a number,
I know that it
it's
converges.
definitely diverge.
You said up here sequence
Yeah.
converges when it goes to a number.
Where the other way that?
All the way.
This here?
No, all the way.
Oh, well, that's a sequence. That's sequence. That has nothing to do with anything.
No, too
But
high.
you
Too high. Way too high. Too
Oh,
high.
it's
Keep going.
always-
Keep going. Keep going. Keep going. Keep going. Too high. Yeah.
yes.
That's only the sequence converge, not series. If I say sequence converge doesn't mean series. Has nothing to do with series. We don't know the series is because at first we start with sequence.
But when it has the summation, that's how you know it's a series.
Yes.
And so when when it has the summation and when you test it to go to 0 and if it doesn't go to 0 then it diverges.
No, the series doesn't have to go to 0. Series. Wait, say that again. Sorry.
So when you have the summation in the question and it has whatever a to the n is, you test the limit and if the limit does not go to 0, if it goes to any other number, then it diverges.
Yes. Good.
It's just for series.
Okay. Yeah. But the sequence can. Sequence can converge. It just don't mean sequence. It doesn't mean nothing to do with series. Like because at first we only deal with sequence. We didn't deal with series yet. Like sequence and converge is like okay, so it's like 1 and 1/2 and 1/4 and 1/8 is going towards 0, so that can converge. But in this case, series is also converge because it's going to be equal to 2. So that is, those two difference because at first we start with sequence. We didn't start with series. Sequence can converge. Oh, by the way, sequence can diverge in two different ways. Sequence diverge. So we're gonna say if limit equal to number, it's okay, right? This is okay, right? This is a converge into a number, but sequence can diverge when limits n approach infinity of a to the n equal to infinity, or when limit n approach infinity of a to the n is equal to oscillation. So for example, -1 to the n, like this, then you will have a -1 plus 1, -1 plus 1, -1, and dot dot dot. When they go to infinite, it's diverged because it's oscillating between -1 to +1. So sequence is different in series. Sequence, I hear they can go into a number. The only time they diverge is they go to infinite or they go into oscillations. Yes. Armin?
It's just okay.
So there's a difference between sequence and series because we start with sequence. Guys, I can only pay attention to one person talking because my eyes is bad, my ears is bad, my brain is bad. You got it? Are you sure? Anybody have any questions? Joshua, have any question?
I just wasn't sure which water bottle was.
You should do an integral test on it. So integral test is CPD. which is continuous, positive. So always know which kind of the test, not only the test, you have to make sure the conditions fulfilled before you do the test. And it's decreasing. So COVID positive die. So that's a one to think about. So that means if F is positive, so F has to be positive, right? Oh, sorry, we already said that. Positive, continuous, and decreasing. Then if you have summation of n equal to 1, infinity, a to the n, and 1 to infinity of f of x dx is either both converge or both diverge. So they can be both converge and both diverge. And one of the two things that you have to know in this particular part on a side note, you have to pay attention to e to the x graph. E to the x graph is going on the left side, it's going to go into a 0. Also, the arctan graph, you have to know really well as well. Yeah, so this is going to be a pi over 2, and this is going to be negative pi over 2. So this will be tested.
Was arcsecant also pi over 2 and negative pi over 2?
No, you don't have to worry about arcsecant. I don't. It's actually a question? No, I thought it was arc10 of e to the x. Yeah, I don't think we have arcsecant.
I don't
Yeah.
think we have an arcsecant.
Maybe we did one.
We have arcsecant.
Oh, yeah, maybe.
Okay, so integral test, sometimes you're gonna deal with inverse trig, you might deal with natural log. So those are two common things that you might deal with. So natural log and inverse trig. Okay, so now what's the next test? Well, we talk about p-series, which is we like p-series. N equal to 1, infinity of 1 n to the p, and p is greater than 1 is what? Diverge or converge? Converge, good. And the p is less than 1, 0, equal to 1 is diverge. So that means 0.99 diverge. That means 0.99 diverge. 1.01 is converge, right? So those are the things. And that comes up to be, hey, that gives us the borderline. N equal to 1 to infinity of 1 over n. We know what the name of this one. What is the name of this one? Harmonic. Harmonic is diverge, right? Harmonic series diverge because what reason? Why do you think it's diverge? Two reasons. P series, right? One. Second, you can do integral test. You can do integral of 1 over x, and that'll be natural log of b when b go to infinity. So two reasons that they are diverge. Now this, we're going to come back to talk about this. That's why I review everything, because we are going to talk about another series looks kind of like this, but it's not exactly like it. Okay, so we talk about p series. Lastly, we deal with the notes on. I think the most confusing part for anybody is the direct comparison test, when to use direct comparison test, and when to use limit comparison test. So today's homework is very important because you're gonna have one section you only do limit comparison test, and the other section you can do any other test. So you can compare the two different tests, because the homework above it is a direct comparison test. Now let me just give you a direct comparison test. So what we did this one, n equal to 1, infinity of 1 over 2 plus 3 to the n. What do we do with this one? 1 to the 3n, is that converge or diverge? Why?
1/3 your ratio, and you're gonna use
Because r is less than 1, right? So therefore it's geometric series. Then this is gonna be a converge situation due to limit compares no, direct comparison test, because you directly compare with another series. You're not dividing by that, you just compare this one. And since this is less than converge, is less than 1 over 3 to the n, so it has to be converged. However, with the second one, we say, hey, and most of people got it wrong on this one, because this one is kind of tricky, because immediately you want to think about you compare to 1 over square root n. But what's the problem with that? What's the problem you compare to 1 over square root n?
Even though it's divergent.
Yeah, it'll be greater. This series is compared to 1 over square root n. So if I compare to this one will be greater than this one, right? But if this is diverge, is this all is converge? No. Claire's like,
No, I was just.
so we gotta make sure, because less than diverge doesn't mean it's converge. Less than diverge could still be diverge. Less than diverge could converge too. So this one, the direct comparison test is inconclusive, not working. So you had to compare with another one. What do you want to compare? What's the best one to compare with? 1 over n. So 1 over n is bigger or smaller than this. Smaller is when n equal to 4, right? So 1 over n is smaller, right? Summation of this, n equal to 1 to infinity. Now, why do I have to set n is greater than 4? Because before 4, it doesn't seem like it's smaller, right? So if this diverge, then this has to be diverge. And that's that. Okay, so we're going to limit comparison test. Limits comparison test. We're going to do one more test today. Limit comparison test. So what's the limit comparison test? Is if you put a to the n is greater than 0 and the b to the n is greater than 0, and you just do the limits. You don't do the series, you don't compare the series, you compare the limits of the ratio of an compared to bn. Is equal to positive and finite, then both an and bn either both converge or both diverge, right? So we start the first question. So we start with square root n over n squared plus 1. What do we compare with? So square root n over n squared. So that's equal to n 1 over 3 half. So what's summation of 1 over n to the 3 half? What is that? Converge. So then you can say, well, which one? You're gonna take the limits of this one over 1 over n to the 3 over 2. So that makes limit n approaching infinity, 3 over 2, that becomes n squared over n squared plus 1. And that's equal to 1, so it's finite. And this is a converge. Due to what? Limit comparison test. Now we're gonna do one more. Did we do this one, last one? n2 to the n and the 4n cubed plus 1. Do we do this one? Okay, so this time I want you to figure out things that you're gonna compare with. what will be the thing that you should compare with?
N to the n.
2 to the n.
I think we already did this. We have finished.
The one where like the original. Yeah.
So we compare this part, right? So can I simplify this? Can I simplify that?
Yeah.
So 2n over 4 to the n square. I think that 1/4 is insignificant because 1/4 multiplied divergent convergent doesn't really matter. So I'm just gonna say, hey, let's name this series 2 to the n over n square. Does anybody know this one's divergent converge? 1 over infinity? Are you sure? It's 1 over infinity though? So we like the first test. The first test, it should be n the divergence test, n approach to infinity of 2 to the n over n square. Immediately, with the intuitive approach, why are you laughing? With the intuitive approach, you should know 2 to the n is going way faster than n squared. But we have to establish a proof for it. How do we prove it? El Hubble rule. So, n approaching infinity, what's the root of 2 to the n? Natural log of 2 times 2 to the n over 2 to the 2n. When they approach infinity, you're still going to get infinity over infinity. And you're going to do it again. El Hubble rule again. M approaching infinity will be Ln of 2 times Ln of 2. And you just realize that's never going to change. And this is just going to become 2. So now when n approach infinity, guess what? It's infinity, right? So therefore is diverge. So if it diverge, then you say, oh, okay, well, this one's diverge. So if we compare to this, if you put a ratio, can you put a ratio and finish this part? And tell me whether it's positive or finite. If it's positive and finite, then both are what? If you don't remember, derivative a to the x equal to ln a to the x. If you don't remember that, still, I will show you how to prove it. Is a to the x. If you take ln y both sides, it'll be x ln a. If you take a derivative of both sides, it's y prime over y equal to ln a. And the y prime is equal to ln a y, which is a to the x. So that's the proof of derivative of natural a to the x. Yes.
How did you get the second? You got two natural logs there. How did you do it?
I just take a derivative. This is a constant, right? I just take a derivative of this.
Oh, okay.
You just infinity.
Missed.
Terribly.
Huh?
Terribly. Where can I hit me?
Yeah.
There.
You're taking a nap. So
I'll get her for you, Mr. Ed.
on Chinese New Year Day,
Bad luck, bad luck.
Lunar New Year, Lunar New Year. We're not offending anybody else. One time I got a very, very fierce argument with a Vietnamese student. I said it's Chinese New Year, and she got super offended. We didn't talk for like 2 weeks.
Wait, that is wrong.
People get offended easily. Okay, so now what we're gonna do is gonna take this,
1 over 4.
and we want to divide it by. Sorry, we're not using a summation. We're gonna say n approach infinity, And that's gonna be 2 to the n over n squared. And if you do that, it's gonna be limit n approach infinity, n to the 2 to the n over 4n to the cube plus 1 times by n squared over 2 to the n. Now, cool enough, they cancel out. So be limit approach infinity, it'd be n to the third over 4n to the third plus 1. And that's equal to 1 over 4. Since they are positive finite, that means what? Both diverge. Both. Right? Because limit comparison test, LCT. So you had to write down which test you did on my test. Oh my Lord Jesus. Yes.
So we know limit n. We know
Oh,
limit
if it's
n
one
of-
fourth, that just proves that it's two positive. Yeah, it doesn't matter.
But you're
what
looking at the other one.
Okay.
We know that diverges because the numerator grows bigger than the denominator like faster, which means that it's not equal to 0, which means it diverges.
Yeah.
Okay.
Or you do a half row test. You find out this series diverge, the other series has to be diverged at the same time. They say both have to be the same.
So El
It-
Hospital rule can be.
So it's actually no.
When can you? It's just take the
1 minute.
top and bottom.
You have one bar. This you diverge. This until they're what?
Okay, last test. Now this test has some branch to it, so this is just the beginning of the test. I want to introduce that makes tomorrow easier. So alternating series tests.
Sure. Can I ask a question about
Yeah.
that? So if the limit n approach infinity ln2 times ln2 whatever yada yada at the on the right there is infinity, that's diverge, right?
Yeah.
So both of them are diverge.
Because we just proved
Yeah.
this has to become up a positive infinite number though.
If that's positive and finite, then whatever you got there is also positive.
Yes.
Okay.
So, what is the alternative series test? That's known as the AST. Okay, so one example, it looks like this. It was look like summation of n equal to 1, infinity of -1 to the n plus m plus 1 of 1 over n. So this is an example. We can come back to prove that this example later. So we're gonna move this to the right. And yeah, it's what we're talking about. That alternating part is this part, right? So this is the name of alternating. So it's alternating, and this is something else. So it's actually, there's a new name for that because we're gonna mention that in a second. But what's alternative series test and what is the conditions? The condition is says let a to the n is greater than 0. And if you have summation of n equal to 1 infinity of -1 to the n a to the n, or summation n equal to 1 infinity of -1 to the m plus 1 a to the n. So why do they say or? What's the difference between those two series? Your first term is what? Negative, positive. Like what Benicia, what Joshua was saying. The first term, this one is, the first term is negative, right? Because -1 to the 1. This is -1 to the 2, so that's positive. So you can start with the negative or positive. So alternate series does not discriminate you start with negative or positive. It's just telling you if it start with positive or end up with negative, it will rotate back in cycles. So if they're in cycles, they both converge. So they converge if two more conditions are met. So two more conditions. Well, what's the first condition we're talking about? The first condition is they have to be alternating. Okay, So this is alternating. So alternating. So you put a check mark, it's alternating because they are either -1 to the n or -1 to the n plus 1. Or it could be -1 to the 2n plus 1. Doesn't really matter. Actually, 2n plus 1. That's not good. N plus 3. It doesn't matter. Yeah. 2n plus 1 is actually all odd. So it's not 2n plus 1. So the first condition is that it's this. Limit n approach infinity of a to the n is equal to 0. Does that look familiar? It kind of looked like n-term divergence test, but if limit n approach infinity a to the n is equal to 0, it does not mean converge or diverge. But now it becomes a first condition or second condition of alternative series test. But they have to equal to 0. So if this condition is met, we need one more condition. The second condition is met is a to the n plus 1 is less equal to a to the n. What does that mean? So what is it decreasing, right? So the thing is decreasing. So you're gonna see that a lot, decreasing. Okay, so if some function is limit a sequence approach 0 and it's decreasing and it's alternating, they are automatically means converge. So this is the converge test, right? This is not both converge, both diverge. This is actually only the converge test. But all the conditions had to be met. Not like divergence test is testing for diverge. This is a test for converge. Okay, I know you love each other. I know it make me uncomfortable. See you guys touching each other.
You're saying weird things to the industry.
McKenna, I don't know how you put up with this, but you're a super powerful woman. Have high tolerance. Like Joshua has like Ethan, has Rylan, has Brendan.
Well, maybe you put it. Don't group me with that chud back there. Whoa.
I know you guys used to touch each other. It's okay.
Yo, you don't say that shit like that, bro. It's live streaming. School, he was like, Ethan, are you gay? And I was like,
Well, I did not say that, did I?
yes, you did. Right there, he's like, yeah, Mr. A, he's gay. Mr. A, he's gay.
It's not the breastfeeding school because I didn't even drop these kids like.
Why you plotted that, bro? You're right.
Okay, so we have 5 more minutes to talk about this series. Okay, so let's go back to this series, right? This one is what we're talking about. This one is copy, and then we're gonna paste right here. So this end up to be, hey, we're gonna see if this condition met. The first condition is this alternating. Check, right? It's alternating because it's -1 to the n plus 1, kind of immediately. 2 is limits as n approach infinity of 1 over n. So you're not including, because this is the an part. This is the an part, right? This is the an part. So if limit approach n approach infinity on a to the n, which is 1 over n in this case, is equal to 0. Check. Okay, you just have to write this down. Third condition. You say 1 over n plus 1 is less than 1 over n. Well, sometimes it's really hard to tell. If you have hard time to tell, you can actually cross multiply. So that's going to be n less than n plus 1, which does that make sense? N equal to odd number is always true. Check. So if those 3 conditions are checked, that means this is converge. And not only converge, it's due to what test? AST. Now, this is actually very well-known series. What's the name of the series? Alternating harmonic. Right? Because summation of 1 over n equal to 1 infinity, this is harmonic. Harmonic series is diverge, but alternating harmonic series is actually alternating harmonic series. It converge. So next time you see automatically alternating harmonic series converge. But let's think about it. Why do they converge though? Let's just say you start with 1, right? And you're gonna have minus half, right? Plus 1/3, minus 1/4. So they go in like this. You go in like 1, come back, come back, come back, come back, come back, come back. So you actually become in between, your sum is going to be between those two numbers. Because you start with let's say you're going right, it's 1, right? Come back halfway, right? Going 1/3 and come back 1/4. And it will be oscillating between those two, 0 and 1. Actually, more specifically, probably 0.5 and 1. Is that okay? So they will converge. Tomorrow we're going to talk about there is small percentage of error, and that's the confusing part. So you have to pay attention tomorrow. So that's why we have built up to here. But I want to ask you, before you leave, like, if you want to practice, I want you to think about this question. N over -2 to the m minus 1. And I want you to think about, is this alternating series? Is this converge or diverge? What is the thing we're going to do, right?
The bottom is bigger than the top. Even though it's popping from negative.
Look at the comments.
More than $1 per week.
She asked about
That's the black girl I have on you.
Alright, so find your boss.
Stop falling asleep. Go home, get a nap.
No, it's alright. To end things with Joshua. I got someone else now.
Got someone else?
Yeah.
Oh, Luke?
No.
Either Luke or Armin.
You need this from him. I said something. I had to end things with Joshua. I got someone else. He said either Luke or Armin.
I know you don't want Aiden.
He says he knows you don't want. No. He did me dirty last year.